Hi everybody, this is the Math 31 optimization review. This is question 9. And this is another one of those classic problems. Okay, a wire, and it doesn't really matter how long the wire is, but we're going to cut it into two pieces. And we're going to use, in this case here, one part is going to be used to make a square, the other part is going to be made into a rectangle with the length 2 times its width. Okay, so let's just draw these shapes here. So the first one's going to become a square, okay? And let's just give it a side length here. Let's say that this is x and x, okay? And then we're going to have a rectangle, okay, whose length with the length 2 times the width. Okay, so whatever the width is here, the length is going to be twice that width. Now, the whole point of this question is actually what we're going to do here is we're going to figure out how to cut that wire, okay, because that wire at 68 centimeters, sorry, I shouldn't put an arrow in the other, I'm always wanting to do that, but at 68 centimeters here, we're going to try to figure out where to cut it, okay, this is going to be some point, let's call that C right there for our cut. We're going to figure out where that cut should be so that part of it is the square, part of it's the rectangle, and where we're going to get the area to be a minimum. Okay, we're going to figure out what those are. Now, this right here, let's say that this is going to be the square, and this over here is going to be the rectangle. If that's the case, then we've got C centimeters going to the square, and the square here is going to have a perimeter of 4x. That also leaves 68 minus C going to the rectangle. Okay, and the dimensions or the perimeter of the rectangle here is going to be, well, that's 1, 2, 3, 4, 5, 6 W's. Okay, so now x in this case is going to be C divided by 4. And in this case here, the width of our rectangle is going to be 68 minus C divided by 6. This will be, okay, the width of that rectangle. Now, what I can do with that, the reason why that was important here is because now I can come up with an expression for area. Okay, and the area here, the area of this square would be x squared, but in this case it's going to be C over 4 squared. So C squared over 16. And I'm going to add to that, well, think about what this would be here. This is going to end up being 2w squared. Is going to be the area of this rectangle. Okay, so that is going to be, oops, sorry, banging into something here. That's going to end up becoming 2w squared. And I'd be tempted at this point to kind of leave it like this. I'll take the derivative using the chain rule in just a moment here. So here's our expression for area in terms of just that variable C. So we're going to figure out where that cut is going to go to minimize that area here. And actually, I know that this is going to end up going to have a minimum here. Or sorry, I shouldn't say that. Actually, no, at this point I don't. I'm not going to say it. At this point, perhaps I don't. So now let's take the derivative. That will end up being C over 8, and this is going to end up being plus 4 times 68 minus C all over 6, okay, and I will multiply by negative 1/6 when I multiply by the derivative of what's inside there. And so there we go. Now, we all know what to do here when we're optimizing. What I'm going to do here is I'm going to set this equal to 0, okay, and I will bring over that second term. That negative is going to make this whole term negative. So I'm going to bring that term over. And so the expression that I'm going to get here is I will get C over 8 is going to equal, okay, well, first of all, I've got a 6 times a 6 in the denominator with a 4 on top. So that's going to be, the denominator when I bring that over is going to be 9. And this will be 68 minus C, which is really just a wonderful little proportion here. I'll cross multiply. Okay, I'm going to move this up over here. And so when I cross multiply, I will get 9 times c is going to get, okay, well, it's going to be 68 times 8, so it's going to be 144, sorry, 544. A fair bit larger than that. 544 minus 8c. I'll bring the 8c over. It'll make that 17c is equal to 544. And so then I'll divide that by 17, and that works out beautifully. And so what that means here is that if we cut and we give 32, so therefore 32 centimeters for the square, right? And remembering that the whole thing here was 68, if we take and put 32 on the square, that means we're going to have 36 centimeters for the rectangle. Okay, now, was that a minimum here? Well, let's just take a quick look at this expression again. I paused a little while ago and I left this, but let's just take another quick look at it. This is going to end up being a parabola. Okay, I've got a c squared here, I've got a c squared here. But notice that this is 68 minus c. But when you square that, you're going to end up with a positive c squared. No matter how you look at it, you're going to end up with a positive c squared here, which is going to be a parabola opening up. So yeah, what we found here is definitely going to be the minimum.